Okay. So I decided to throw op amp there. Just refresh your memory with op amp. And the question here, can you find the ratio of V out as a function of time over Vs as a function of time? Because I didn't give you what Vs is, the source. That's what we call the voltage gain, AV. That's the voltage gain. If the number is 3, that means V out is going to be 3 times Vs. If the number is 0.5, V out is 0.5 Vs. The only thing we don't know, since we don't know what Vs is, we're going to assume that the voltage across the capacitor 0 minus happens to be 0. Because we don't know what the status of Vs, how long it's been going on, what kind of a circuit we have here. So assume Vc as 0 minus is actually 0. And the reason we make that assumption, again, to take you back, if you recall, we said when you have a capacitor, you can place the capacitor with 1 over SC with the voltage source plus to minus V0 over S. So since V0 is 0, it's gone. Or if you're going to use this one, you replace it with the current source of value of 0 here, and that means that's gone. So that's why. So I'm going to convert this to an S domain. So this will be Vs as a function of S. The resistor stays the same. The capacitor is 1 over SC. 1 over SC, which means 1 over S. C is 1. The resistor is 1. The resistor is 1. 1 over SC. 1 over S. And V out as a function of S. So let me find what is V out as a function of S over Vs as a function of S. Once I have that, I'll do the inverse Laplace, and I'm done. Going back to op amp, there's a couple of things that we know. We know the voltage V plus equals V minus. So what is V plus here? If this is my ground, what's the voltage here? 0. So what's the voltage here? 0. The other assumption we made is what? The current going in this direction is what? 0. I in going to that op amp from this end is going to be 0. So is the current coming out of this end. These are the two assumptions we made. That the voltage here and the voltage here are the same. The current going in here and the current coming out of this end, both are zeros. So if I stick with that assumption, this is V out. That means this whole node up on the top is what? That's also V out. It's only a wire connecting them. This is Vs here. This is 0. I don't know what that is. Let's call that what? Vx? Because we don't know what that is. And let's assign current going in or coming out. It doesn't really matter. You pick and choose which way you want the current. I'll make my life easy. I'll just go I1 without thinking, I2, I3, I4, I5, so I assign current in and out. Doesn't matter which direction you make the assumption. It's not going to change anything. I'm going to do KCL at this node. KCL. KCL at Vx. KCL says if you add all the current going in to that node, it should equal all the current leaving that node. What is going into that node? I1 plus what? I sub 2. And what's leaving that node? I sub 3 plus I sub 4. I sub 1, it's this voltage minus that voltage. Vs minus Vx divided by 1. I sub 2 is this voltage minus that. So V out minus Vx over 1 equals, I sub 3 is this one, Vx minus 0 over what? 1 over S plus Vx minus 0 over 1. And that's easy to clean. Vs minus Vx plus V out minus Vx equals, this is S times Vx plus Vx. If I move these Vx's to that side, this is S here, just in case. So I have V out equals Vx, 2Vx, 3Vx, 3 plus S times Vx minus Vs. I got a little problem. I got that Vx there. I need to get rid of Vx. I have basically two unknowns right now, V out and Vx. Vs, we assume we know it because we're doing the ratio of V out to Vs. Like if you know Vs, can you find V out? Well, I got V out and Vx are my two unknowns. Well, if you have two unknowns, how many equations are you going to need?
Two equations.
Two. I need a second one. Where's the second one going to come from?
Can we do KCL at?
This one?
Yeah.
Yep. So KCL at V minus, that's this one right here, which is the 0. The current in equals the current out. What's going in is I sub 4 plus I sub 5. And what is leaving? The 0. I sub 4 is this current, which is Vx minus 0 over 1 plus I sub 5, which is what? V out minus 0 over 1 over S is equal to what? 0. Vx minus S V out is equal to 0. Vx equals what? S times V out. That's my second equation.
Wait, why is it minus SV out?
Plus, minus. Because I was tired. Just want to make sure you're paying attention. So now we get two equations by two unknowns. Can we do a substitution? We know what Vx is, or replace Vx by what? Negative SV out. So let's see what's going to happen. V out equals 3 plus S times Vx, which is what? Negative S V out minus what? Vs from this equation. Now, since these have V out, let's bring them to one side. V out plus S times 3 plus S V out equals negative Vs. I can factor V out out. And if you expand this, what's S times S? S squared plus 3S plus the 1 equals negative Vs. V out over Vs is going to be what? Negative 1 over S squared plus 3S plus the 1. Now we're going to take the inverse Laplace. You can do what you learned in differential equation, and that is complete this square, make it sine square and cosine square, that's fine. Or we can solve this, find the roots for that using the quadratic formula, and make it a simple one. Because if I take this one, S squared, come back here. Come back here. There we go. So if I take S squared plus 3S plus 1 and solve it, see what makes it 0. This is minus 3 plus or minus the quadratic formula, which is what? 9 minus 4 times A times C. 4 times 1 times 1, that's 4. All divided by 2A, which is 2. If you do the math, one of them is going to be negative 0.36. The other one is going to be negative, or 38. The other one, negative 2.62. That's the answer, which means if you bring them to this side, you can factor that as S plus 0.38, and the other one's going to be what? S plus 2.62. Remember, these are the answers. You bring them to this side, it becomes S plus. So you can actually take this problem now and rewrite that as negative 1 over S plus 0.38. S plus 2.62. Now, if you don't believe me, if you FOIL this one, what's S times S? S squared. This is 0.38S and 2.62, that's the 3S. What's 0.38 times 2.62? That's the 1. A little bit easier than completing the square. So here we go. V out over Vs is equal to -1, so I can throw that sheet of paper away. Which I can write that as A over S plus 0.38 plus B over S plus 2.62. I can do that. If I know what A and B are, I'm done. Does it look focused? Looks fine? Okay. From my angle, looks like a little bit fuzzy, or maybe my eyes are fuzzy. So to find A, we can use our shortcut techniques. A is sitting on top of S plus 0.38, that's this piece. So it's -1 over, whatever this expression minus that piece. And you want to find that when S equals what? Negative 0.38. And there's my calculator here. So 2.62, oh, wait a minute. I forgot, I gotta go to calculator first, okay. F18, okay. 2.62 minus 0.38, and it's 2.24. And when you divide them, that's a negative 0.45, roughly. Is that what you got? B equals -1. B is sitting on top of S plus 2.62, so this piece is gone. When S equals what? Negative 2.62. I'm assuming the bottom is going to be negative 2.24 here, right? Which is positive 0.45.
How you doing? We got it, man. Come on.
So V out over Vs as a function of S is going to be A, which is negative 0.45 over S plus 0.38 plus 0.45 over S plus 2.62. And now the last step, take the inverse Laplace of that V out over Vs as a function of time is going to be what? Negative 0.45. What is the inverse Laplace of S plus 0.38? E to the negative 0.38t plus 0.45 e to the negative 2.62t.
Is that the right answer?
Well,
Check it, or?
it is, but there's something they added too, I don't know. Notice here, V out over Vs is -1 over S plus 2.62, S plus 0.38. But then when they go to this page, they go V out, so I don't know where the S came from here. So it was fine here, because now they're saying V out equals, so they must have given you what Vs is, but I didn't see Vs anywhere in the problem mentioned. Unless somewhere there's, because if you look at the next one, it says V out equals. So it's not V out over Vs, so they must have known what Vs is for the second part, and they plugged it in. So that changes the expression a little bit. But for that one, the answer is yes. What we found is fine. And I don't see anywhere here, quickly, I was scanning to see if Vs was given to us, and I don't see it. So I don't know where that came from, you know. Either they screwed up or something is not right. Okay. Maybe I'll do one more, then we'll be done with this chapter. And we can next class start with body plots and the other stuff. So let me take one, might be a little bit decent. Oh yeah. Let me just go to the end here and take something good, like substance. There's homework. Let's see, do we have anything that's like it looks crazy? Okay. I'm looking for trouble here with this problem. I'm not going to be happy with myself, but I saw one like it looks like this. I'm just looking at the clock. Do I have enough time? But look at the sources. 6 cosine 2t minus 13. There's a phase shift. You know what the Laplace of that's going to be.
Well, doing 2 loops took like ages.
You know, this one here, it looks okay. Couple of sources here. We could probably do it. Any preference? Which one you want? I really don't care. I just might not be able to finish the last one with the time we have left.
I don't want the phase
Which one?
shift. I'm curious about the phase shift.
This one? I'll answer your questions after. Joe, I heard you. So we're going to do this one. That's probably doable in the time we have. 14 u sub t. Ten, 600 microfarad. Dependent current source. And the value of that 3 times V2. The ground is on the bottom, I'm just not drawing it here. There's a current source pointing down, 5 times V2. This is V2 right here, 500 microfarad, and 2 Henry. 2 millihenry, I'm sorry, millihenry. This one from our book on page 615. If you're interested in that, Joe.
It is in our book?
Yes,
All right.
615.
Does it give you a walkthrough at all? Or?
No,
Okay.
just a homework problem at the end of the chapter. Okay. Change it to Laplace. Here's the good news before I do that. There's only one source that says u sub t in it. See that? That means what? For t less than 0, what was my sources? What was my source in the circuit equal to? That's a dependent source, so that depends on something else. So this is the only source. So for t less than 0, the value of this is what? 0. That means all the current through the inductors, all the voltage across the capacitors are 0. There's no sources there. And again, the reason we're interested in that, because I showed you that more than once, and that's when you look at this circuit, you have to plug in the initial conditions. So if you see them 0, just say thank you guys, because they just made it a little bit easier on us.
Is there any reason why we would replace with the parallel?
Well, if you have a lot of elements in parallel, then you can use KCL, right? So that would be the case. You have to look at your circuit and see which one would be easier, if I put this or if I put that. If you have a lot of elements in parallel, use the parallel, you can use KCL, you know. So I'm going to switch my circuit to Laplace now. The Laplace of 14 is what? 14 over S. The Laplace of 10 is 10. 1 over SC. So let's do my calculator here. 1 over SC. 1 over 600 micro. What is that? 1 divided by 600 micro. Where's my EE on this, or EXP? I didn't use this calculator in a while. Oh, here we go. Micro is 10 to the minus 6, right? This number roughly, approximately, 1667 over S. Three V2 as a function of S, 5 V2, this is V2 as a function of S, S times L, L is 2 milli, what's that, 0.002 S, right? And that value 1 over SC, 1 divided by 500 micro, 2000 over S. I just don't like that number. Like, I wish they gave us some nice numbers. Should we change that to 400 maybe? I'll leave it. I just didn't like that 1667. If they made it 400, it will be 1 divided by, what is it? 1 divided by 400 e to the negative 6. That would have been like 2500, would have been a nicer number. But we'll leave it. That's what was the problem there. Okay. And the question is, assuming no energy initially stored, well, obviously from the circuit, determine the value of V2. So find V2. Then after that, they say, okay, if t equals 1 millisecond, t equals 100 millisecond, t equals 10 second. So you can plug it in. First we'll find as a function of t, then we'll plug in the values. Then they go, what is V2 at 1 millisecond? What's V2 at 100 millisecond? You know, they take us through trying to find out what's going on there. and the next one at 10 second. Well, if you know what V2 as a function of t, then you're done with the rest of them. I can do KCL again. Which one you want this current going?
Towards V2.
Towards V2, okay. We'll call this Vx. We know this value, Vs is known, so there's only Vx and V2, two equations by two unknowns. Sounds straightforward till we start doing the math. We'll see how ugly it gets. KCL at Vx. The current going in, I sub 1 plus 5V2 plus 3V2. And what is leaving? I sub 2. This current going in, that current going in. This current going in, that's leaving. I sub 1 is 14 over S minus Vx over the sum of these two. 10 plus 1,667 over S. It's this voltage on this end minus that voltage over the sum of these. I can make that 8V2 instead of 5 and 3. And what is I sub 2? It's Vx minus what? V2 over 2,000 over S, right? Now, if I multiply everything by S here, the top and the bottom of this fraction, just this fraction, I can clean it just a little bit. I'll have what? 14 minus SVX over what? 10S plus 1,667 plus 8V2 equals S times Vx minus V2 in parentheses here divided by 200.
2,000.
2,000, thank you. No, not really nice. The LCD is like, ugh.
Feel like you're gonna have to get creative with this one.
Yeah, the algebra is not going to be nice.
But what you could do
Mathematica.
is I guess you could do that. Well, you have a 10s plus 1,667 on this side, right?
Yep.
So what if you multiply the other side by 2,000?
You multiply by the LCD, which is this times that. Yeah.
Oh, right.
So if you multiply by the LCD, which is this times this, you end up, when you do this, you end up with 2,000 times 14 minus SVX plus 2,000 times 10S plus 1,667 V times 8V2, because that's your LCD, equals 10S plus 1,667 times S times Vx minus V2. I don't know how much nicer this looks now, but still looks ugly. I just don't want to have to go through that. I guess I don't have a choice here. 2 times 14 would, yep. 2 times 14 is that 28,000? Minus 2,000 S VX plus, is that 20,000 S times 8? Because 8 times 2 is what, 16?
So.
160,000?
60,000.
SV2, and the other number will be, let's see if that number becomes a little bit prettier there. 2,000 times 8 times that number. Got even uglier. What did you get? 2, 6, 6, 6, 7, roughly. Let's see. 6, 7 V2, something like that. Who picked this problem? 10S squared plus 1667S times Vx minus V2. We're still going to clean it. Let's see if I can stay focused and try to combine them in one step. I see the Vx, see the Vx here? And I see this has the Vx, and that's it. So if I leave the 28,000 on this side, or when I take that number to this side, it becomes a plus 2,000. And 16 with an S, and I have 16, so what is that? 1, 6, 6, 7 plus 2,000, 3, 6, 6, 7. So I'm going to have 10S squared plus 3, 6, 6, 7S times Vx. Let's see the V2. Minus 10S squared. I took the minus sign out. When I bring this side to this, that becomes a minus. Add it to the S here. 160,000 plus 161,677 plus 2666700 V2. I think I'm okay. That's my first equation. God help me. I got to come up with another one. Once I saw that number 16667, I knew I'm in trouble there. Now we need to come up with another equation. That's one equation by two unknowns. Hopefully I didn't make a mistake with it, but if I did, I'm giving up on it. No. The other equation I can use is right here. KCL at this node, at V2. What's going to that node? This node. I sub 2 is going to it, and what's leaving? I sub 3 plus what? 5 V2. This current is coming up, so it's leaving that. This is going in, this is coming out. I sub 2 is Vx minus V2 over what? 2000 over S. I sub 3, V2 minus 0 over 0.002 S plus 5 V2. S times Vx minus V2 over 2000 equals 1 divided by 0.002 500 V2 over S plus 5 V2. Again, your LCD is 2000S. So if I multiply by 2000S, you will have S squared Vx minus V2. 2000 times 500 1,000,000 V2 5 times 2000. What is 5 times 2000? Is that 10,000? S V2. If you multiply this, S squared Vx equals S squared plus 10,000 S plus 1,000,000 times V2. Vx equals that's what Vx is. It has to be a way on the TI-89 I can type in these and simplify it. Because if you look at this one here, I have one, but I don't know how to do it on it. I don't know if it does it or not. If you look at this, you can take an S out if you want to. Six, 6, 7, 0, 0, V2. That's the equation here. And we know what Vx equal to. We just did the Vx in terms of V2. So if you plug it in, I better move on the side right really small. In place of Vx, let me write S squared plus 10,000 S plus 1,000,000 1 times 10 to the 6, that's a million. Minus 10s squared plus 161,667s plus 2666700 V2. So now how many unknowns do we have? 1. If we can just simplify the algebra, we'll be in good shape. This s cancels one of these. Multiply by s. I will have 10s plus 3667 times s squared plus 10,000s plus 1 million V2 minus, I'm going to have an s here because next to s I'm multiplying by s, 10s squared plus 161,665. Oh, that's an s, not a 5 even. That's a s plus 2666700 V2. I go, because I saw something which I kind of liked quickly. The s cube will cancel each other out. What's that? 10s cubed, right? And what's this? Negative 10s cubed, right? That's gone. So these two cancel each other out. Let's see what the rest of them are. What about this one? Is that 10,000s squared? Is 100,000? 10,000 times 10 is 100,000, yep. And 10 times 1 million is what? 10 million? S? And what about this one? 3667s squared. 3667s squared. And what about this one? That is 3667 times 10,000. Move the decimal point 3 places to the right. 36,667,000 S's plus, oh God, 3,667 million. All of that with V2 in them. All of it. I already canceled the s cubed, so this is gone. This would be minus 1,667 s squared. This would be minus 2,667,00 s, all this times V2.
So there'll be a plus on the outside?
I'll go like this, yeah. And now we're just gonna enjoy this. 100 plus 3, 103,667 s squared. 10,000 plus 36 million s. 36,667,000 plus 10,000 or 10 million? 10 million minus Oh, wait a minute, I forgot to subtract the s squared from that, right? That's this piece. This will be plus, I'll put that under it. That number, 3,766,700 S. I'm gonna have minus under it from the other one. 2,667,000. Oh, wait a minute, the numbers might work out. And the last number is gonna be what? 3,667 millions. V2. So here we go, 20,000 S equals 103,667 minus 161,667 equals, what do you know, minus 50, I don't know if it's 50,000 or 58,000, I can't really tell.
Let's see for your S terms.
Yep.
I think it's supposed to be oh, sorry, never mind.
I think this one, I can't really tell if that's 50,000 or 58,000. I'll go 58,000. Yeah, it's 58. And this number, 3,000,007.
I think something's off with the S, the first S. That's supposed to be the 10 million plus the 36 million.
10 million
That's the 36.
and 36 million, is that what, 46 million?
And then minus that other.
Yeah, that's a 46 million. Who the hell came up with this problem?
So something like this won't be on the exam, right?
Well, it's hard when you look at them. It's hard to tell. Like, it doesn't look it's going to be that bad. 46,667,000 minus 2,667. 2,667. I don't know what that number is. 46,667,000 minus 2,667,000. Oh, you gotta be kidding me. Oh, wait. 46,667,000 minus 2,667,000. 4, 6, 4, 0, 0. I have a 3 here, but I doubt the 3 is the right. Probably a 0 should be there.
Yeah, it's 4, 4, 6, 4, 0.
I think that's supposed to be a 0 somehow, probably an error there. The reason I think that, because you can cancel a lot of the zeros here. That's why I think it is.
Because you rounded a lot, it's supposed to be like 46,666,666 to 26,666.
So we'll make that a 0. I think that's probably a rounding error there. And the reason I like that, because I can drop 1,000 out of each one now to make the numbers more manageable, a little bit there. So you get 28S equals negative 58S squared plus 46400S plus 3667000 V2. And to get V2 as a function of S equals 28. I'm going to take the minus. I never like to start with the minus here, so I'll put it on the top, and that reverse all the signs for me. And now take the inverse Laplace. I give up on it. I got a headache. You can divide by 58 to shrink the numbers. If we divide by 58 to make that a 1,
Those are quadratic formulas sitting on the TDI calculators.
yeah, some people might have it. So if I factor out, if I divide by 58, every one of them, I have,
Did you want to divide by what?
now I want to make this a 1.
Oh,
This is just a rounding, negative 0.48 over s squared. This will be 400 divided by the 58, 800s minus, I'll dive this really nice number here, 3667000 divided by 58. I got 63224.1. I'll drop the 0.1. So if you decide to use the quadratic formula to find the answer to this,
Oh, that's an S term in the numerator.
yes. If you decided to factor that, minus, that'd be plus 800, plus or minus the square root of 800 squared, minus 4 times A times C, divided by 2A. Take the square root of that number. Where's the square root on this? Where'd you go?
so where the times is multiplication table.
Multiplication table.
Multiplication sign.
Oh, yes, thank you.
There's also a negative inside for the C term. It's negative 63224.
Oh, that'll make it a plus here, right? So let's see what that answer. Clear.
Good catch, David.
Can't escape. Quit. So let's find that number. 800 squared plus 4 times 63224. Get a number. Let's take the square root of that number. Stupid thing, escape here. I have to close the parentheses on this, I guess. So it's 800 plus or minus the square root of 945 roughly, divided by 2. Approximately 945.
Yeah. I see.
So 800 minus 945. It's negative 145 divided by 2. So one answer, it's negative 72.5. The other answer is going to be 800 plus 945 divided by 2. Clear. 800 plus 945 divided by 2.
872.
872.5, right?
Yep.
That means one of these factors is going to be s plus 72.5. This factor will be s minus 872.5. Oh, I wanted to give up on this a long time ago. So this will be a over. Remember, what we have here, this problem now can be written as negative 0.48 s over s plus 72.5 s minus 872.5, which you can write as a over s plus 72.5 B over S minus 872.5. Find A and B. Negative 0.48 S over S minus 872.5 when S equals what? Negative 72.5. Negative 0.48 times negative 72.5, 34.8 on the top. On the bottom, negative 72.5 minus 872.5.
Negative 45 is what I got.
The bottom,
Yeah.
they're both negative.
Yeah, negative minus.
945, right?
Yeah.
Yeah,
That's
that's it.
what I
Okay.
said, negative 945.
Okay. So now 348.5, 348.8 divided by that number is negative 0.037.
Yeah.
And B is going to be B is sitting on top of S minus 8, so it'll be S plus 72.5, and you're going to find the value when S equals 7 plus 872.5. Negative 418.8 over. That's, I think, 945 here. .443.
Negative 0.4.
Negative, yeah.
It's there.
So now what is V2 as a function of time? I know what A, which is what? Negative 0.037 e to the power of negative 72.5 t. This will be minus 0.443 e to the power of positive 872.5 t u sub t. Right or wrong, I'm keeping it.